everyone, so today we're going to go over lesson 5 of logarithms. It's going to tie into what we did on lesson 4, but we're going to continue moving forward. So at the top here we have different steps on how to solve for logarithms. It's kind of similar to trigonometry where you're given a variable to look for and there's some 3-letter word in front of it. It's very similar steps and you'll see what I mean as we go through the questions. But basically for all these steps, you're going to do for step 1, bring all the logarithms to one side and all the whole numbers to the other. You're going to write the logs as a single logarithm, so there should only be one log, and then you can convert it to exponential form. And then lastly, as always, we're going to solve for the unknown variable. Normally it's going to be x, but there could be some cases where it's going to be a different letter like z, a, and so on. So for example 1 here, we have solve for x, we have 3 log 2x equals 12. So for this one, this is one of the more basic questions where it only requires a few steps. So the first thing you're going to do is check for the coefficient that's attached to the log. Here we see it's 3. And just like any other variable, whenever we see a number is attached, we know it's being multiplied. So in order to isolate for x first, we're just going to divide both sides by 3. Now we're going to get log 2x is going to be equal to 4. Now at this stage, we could just do the switch method I taught you guys in an earlier lesson, where now the 2 gets attached to the 4, and then the x goes into the other side of the equal sign. And then our last step is we're just going to simplify 2 to the power of 4, which is going to be 16. So x equals 16, and that will be our answer in this case, and don't forget to box your answers. For letter B, this is going to be very similar, except now just one additional step. We see we have a constant, which is negative 8. So as always, whenever we're solving for a variable, we're going to move the constant first. So here we have a minus 8. That means we're going to add 8 to both sides. That gives us 5 log x equals positive 5. And now this is very similar to letter A, where we just have a coefficient in the front of logs, and now we just divide both sides by that coefficient. So here we have log x equals 1 now. And now we're going to the next step. This is usually the step where a lot of students mess up because they're like, oh, what number do I write as my base number now? I don't see anything. So this is where you have to really remember that if you don't see any number beside log, or any letter in this case, or any cases, that means there's an invisible 10 here. So really, this is going to be a 10. And now 10 has a 1 attached to it. So 1 equals x, and then x equals 10. And that would be our final answer. So again, if there is no number or any letter that's like in the little base function here, that means there's an invisible 10. Letter C, so this one's a little more complicated because the argument has a plus and a minus sign, but that's okay. It's going to be very similar to factoring. So from lesson 4, we see that if there's a plus sign or a minus sign separating two logs, that means you're going to use multiplication or division law. So in this case, we see there's a plus sign. That means we're going to be multiplying these together. So here we have log 4 in brackets, and our arguments are going to be multiplied together, so x plus 1. Do not forget these brackets. It is super important you keep them because they are worth half a mark, and they also influence the rest of your answer. Times x minus 2 equals 1. And then now at this step, a lot of students see this and get overwhelmed because the argument looks so big, but you're just going to do the exact same thing as we did earlier, where if you see you're at the stage where you have a single log, all you're going to do is you're going to switch places of the argument and on the right side the equal sign. So now the 4 has the 1 attached to it, and now on the right side we have our whole argument. So it's going to be x plus 1 times x minus 2. So basically the argument and the number on the right side gets switched around, and it's the same case for all the other ones, except for on the other ones our arguments were just a single x, so it doesn't look as complicated, but it's basically the same steps. You just switch the argument and the whole number on the right side, and then you get this stage. So now from here, as you can guess, we're just going to be FOILing it out or distributing. So here these get FOILed out, and you're going to be left with 4 equals x squared minus 2x plus x minus 2. And if you simplify that and you move 4 to the other side, you're going to get 0 equals x squared minus x minus 6. And now we start factoring. So 0 equals x minus 3, x plus 2. So now we're left with two answers here. We have x equals 3 and x equals negative 2. So in logs, it's super important to check if both of these answers are acceptable or not. And this is the case for all questions, even the basic ones here. I didn't do it in these ones because I just want to get you guys started off on an easier note. But here, this is when you start checking from now on. So we have x equals 3, and what you're going to do is you're going to look at the original equation and look at the arguments. So here it's x plus 1 and x minus 2. What you're going to do is you're going to plug in your x equals 3 into these arguments and see if it gives you a negative number. If it gives you a negative number, that means it's going to be an extraneous root because you cannot have a negative log. So here we have x plus 1, which turns into 3 plus 1, which is 4, that's positive, and then 3 minus 2 is positive 1, it's also positive, so this one is acceptable. Now I check for minus 2. So negative 2 plus 1 is going to be negative 1, and right away we know that this is going to be an extraneous root because it gave us a negative log. And you must write that, you must say extraneous root. This is worth half a mark to a full mark depending on the question, and you must say this. Oops, do not box that, I just did it out of habit. But you just put a little arrow and say extraneous root, and then now you're done your question. You also need to box your answer just so the reader knows, or whoever's marking your exam, or test, aka me for the test, that you accept this answer. You're saying x equals 3 is an okay answer to have, but the other one we reject. Oops, went too far. Oh, and I charged my Apple Pencil all the way this time, so it shouldn't be dying. So, good news for us. So anyway, moving on to letter D, I'm going to show you two different methods on how to solve this question. And a lot of students tend to go towards the second method, but there are a lot of cases where students prefer the first one, so I'm going to show you both. The first one's just a slightly longer. So I'm going to draw a little line in between just to indicate we're doing two different methods. So on the left here, I'm going to use a different color. We're going to use black. What you're going to do here is, wait, did I finish? Yeah, I did finish. What you're going to do here is you're going to bring all the logs to the left side of your equal sign. So you're going to get log 2, x minus 2, plus log 2x, and minus log 2, 3 equals 0. From here, we see there's plus and minus that are separating the logs. That means we're going to have a little fraction with one giant log, since they all have the same bases. So here we have log 2, bracket, and then what goes in our numerator will be all the positive logs. So x plus 2 times x, and then in the denominator it's going to be the negative log. So here it's just going to be 3. Some students feel a little iffy about this because they see in the numerator there's variables and the denominator there's none. That's completely okay and that's perfectly fine. Here, bracket equals 0. And when we're at this stage, we see we have one single log. So now we can do the little switch method. So now the 2 has the 0 attached to it, and on the right side it's going to be our argument. So x plus 2 times x over 3. So 2 to the power of 0 is going to be 1. Anything to the power of 0 will always be 1. Do not write 0. That's a common mistake a lot of students make. Just make sure you remember if the exponent is 0, it's 1. And here I'm just going to FOIL it, so it's going to be x squared, not plus. Or wait. Oh, oopsie, I wrote these wrong. It should be minus signs. Minus, minus. Minus 2x over 3. And then now we want to get rid of a denominator, so it's going to turn into 3 equals x squared minus 2x. And we're going to put everything on the same side and factor. So we're going to have 0 equals x squared minus 2x minus 3. And 0 equals x minus 3 and then x plus 1. And then lastly, we just have to solve for x's. So here it's going to be x equals 3 and x equals -1. So at this stage, you need to check, do we accept both answers, or is one of them, or maybe both of them, are an extraneous root? So here we plug in 3 into our arguments. So 3 minus 2 is going to be a positive number, and that's fine. And here we have a single x, which will be a positive 3, so that's also okay. So we approve of x equals 3. Now the next one, we have -1. So we plug in -1 into the first argument, -1 minus 2. That's going to give us -3, which is a negative log, and we can't have that. So this is going to be extraneous root. One thing I want to note is that not all negative numbers will always be extraneous. Because for example, let's say I gave you log -x. If I give you log -x and you had a -1 as your answer, that'll turn it into a positive log, so that's correct. That would be an acceptable answer. So just because your answer at the end here is negative, that doesn't always necessarily mean it's going to be extraneous. You always have to check and plug it in. So now on the right side, I'm just going to go show you guys a second method. It's a little quicker, and I prefer this method, but if you don't prefer it, that's perfectly fine. So what you're going to do is you're just going to have the left side and the right side completely the same. And you're just going to condense everything together. So here we see on the left side that there's a plus sign separating the two logs. So we know right away that's going to be a multiplication law. So here it's going to be log 2 bracket x minus 2 times x equals log 2, 3. Some students like to jump right away and just write 3 on the right side. You can't do that at this stage because we're still condensing the left side together. So you would just leave the right side exactly the same. Now at this stage, when we have one log on both sides, we could drop the word log and we could just solve for x and just solve for the arguments. So here, now we're just given x minus 2 times x equals 3. And we're just going to FOIL and solve everything out. So x squared minus 2x equals 3. It's going to look exactly the same from here as the left side. And we know from the left side that x equals 3 is acceptable, and this is extraneous. So right away, just looking at these steps, this second line here, where is it? Is very similar to this stage. So you kind of skipped like 4 steps by doing the right method, or the right side method, I mean. But if you don't feel comfortable with that, that's perfectly fine. You could go do the left side if this is more of your forte. So here for letter E, I'm going to do the right side method where we just keep the left side and right side where it is. So we see that all of them have a base of 4, so we could condense everything together. So we have log 4, and we see that there's a minus sign separating these two logs, so we know right away that this is going to be a fraction. So in our numerator, we're going to put the positive log, which is going to be x squared plus 1. And then our denominator is going to be the negative log, which is going to be 6. Then the right side is going to be exactly the same. And now at this stage, we see we have one log on both sides, so that means we could drop the word log and just solve for our arguments. And here, get rid of 6, it's going to become 30 on the right side, so x squared plus 1 equals 30. X squared equals 29, and x equals plus minus square root 29. So do not forget the plus minus sign. I know we've seen this in previous units, but I'm going to keep reminding you, if you square root a variable, you have to put a plus minus sign. It's just a rule. So here we see x equals positive square root 29, and x equals negative square root 29. So we're still going to check for both arguments, are these answers acceptable? So here, we see that we have x squared, right? So if you have x squared, we plug in positive 29 plus 1. We know this is going to be a positive log, so this is acceptable. And a lot of students see the negative square root 29, and they say, oh, negative. it means I'm going to reject it. You can't do that because in this case, we actually accept this answer. Because if you plug in negative square root 29 into x squared, remember, negative times negative is always going to be a positive number. So this is going to be a positive number plus 1, which is still a positive log. So this is a case where you accept both answers. So there are no extraneous roots. So once again, if you plugged in negative square root 29 into x squared plus 1, this turns into negative square root 29 times negative square root 29 plus 1. And then the negative signs cancel out. And then everything's all positive. So that's why we accept both answers. And it's always important to check, because if you use that extraneous root, you would lose a full mark for that, because that means you're being lazy. Alright, on to letter F. So here for letter F, we see we have a constant number, and then we see we have logs. So I'm just going to put the constant number on the right side. So here we have log 4x plus log 4 bracket x plus 6 equals 2. And then now from here, we see we have the plus sign. That means you're going to use multiplication law. So it's going to be log 4 bracket x times x plus 6 equals 2. And then now at this stage, we could do the little switch method where now the 2 gets attached to 4, and the right side, the argument, goes over there. So if we simplify everything out, this becomes 16. X squared plus 6x. We move the 16 over. 0 equals x squared plus 6x minus 16. And then if you factor this, it's going to be 0 equals x plus 8 and x minus 2, which leaves us with x equals negative 8 and x equals positive 2. And now we check, can we accept both answers? So here right away we see negative 8. If you plug in negative 8 in either of these arguments, it's going to give you a negative log. So we reject this one and we say extraneous. And now we check with positive 2. Positive 2 is acceptable, so we box this answer. And now, I think this is the last one. Yep, this is the last one. So here, this is one where it gets a lot of students and they feel very troubled at the start. And honestly, the first step is where a lot of students go wrong. So make sure you pay attention to what I'm about to say. So looking at this question, a lot of students get overwhelmed by the 2 at the front here. And they think, oh my gosh, it's a 2 coefficient. That means I have to divide everything by 2. But if you divide everything by 2, that's going to give you a bunch of different fractions and make the work a lot more complicated than it needs to be. So I want you to pause here and think to yourself, what options do I have to go forward with the coefficient? What can I do with the coefficient? You could either divide, which we just said is a bad idea, or from based off previous log rules, we could turn this into an exponent. So here we're going to rewrite everything, and this turns into log x squared. And now you rewrite everything else. Log bracket x plus 2 equals log 2x minus 3. And now we could continue on like a regular question. So here, I'm going to put everything all together. Well, not everything all together, but I'm going to do the left side first. So on the left side, we see we have a minus sign, which means division law. So log, and then our giant bracket, and the numerator is going to be x squared. Then our denominator is going to be x plus 2, because that's the negative log. And on the right side, it's exactly the same. Now at this stage, we see there's one single log on both sides. That means we could drop the word log and just focus on the arguments. So x squared over x plus 2. And I'm going to tell you, keep your brackets here because it's going to make a big difference later on. And then here we have 2x minus 3. And the same thing, keep your brackets. Do not drop the brackets yet. So 2x minus 3. Now, we're going to multiply both sides by x plus 2 to get rid of our denominator. So we're going to have 2x minus 3 times x plus 2. So I'm going to write in red what sometimes some students do, and this is wrong. So the red means wrong. Do not do this. So some students will write x squared equals 2x minus 3 times x plus 2. And then they would only FOIL the negative 3, which would give you a wrong answer. And another thing some students do wrong is they will FOIL it out properly, but because there's no brackets, that would actually be wrong notation, and you will be deducted a full mark because you did not carry forward your statement. So you know you did technically the right steps, but because you didn't draw the bracket, it will be considered wrong based off your math and what you stated. So now we're going to continue on with this line. So we have x squared and these brackets, and you're just going to FOIL. So it's going to be x squared equals 2x squared plus 4x minus 3x minus 6, and 0 equals x plus 3 and x minus 2. And now, well, I kind of skipped a step, but basically I simplified this, so I should say that. Where this turns into 0 equals x squared plus x minus 6. So I kind of skipped that, but yeah, that stuff should go in between these two. So here we have x equals negative 3 and x equals positive 2. And we check, do we reject any of these answers? And right away, even just looking at the first log, we see we reject a negative 3. So here, extraneous. And we check, do we accept the positive 2? And then we do, because here, if you plug in 2 in the first one, that's positive. 2 in the second one, 2 plus 2 is 4, positive. 2 times 2 is 4, minus 3, still positive. So you accept this answer. And now you're done. So that's it for lesson 5, and I'll continue making videos for the rest of the units. But just make sure you're still attending class and asking questions, even if you're watching the videos, because I know, again, as I said last video, that there's a difference between being in person and seeing it live versus watching a video. And I know in person I tend to do a lot of more hand gestures, which some students find to be amusing and also helps them remember. But anyway, that's it for today. Bye!